So in part one of our video for like terms, we looked at dealing with variables with apples and bananas. If you haven't watched that video yet, I would recommend watching that first. Because in this video, we're now going to say, well, what if we don't want to have to deal with apples and bananas anymore? Because often, instead of A's and B's, our letters are X's and Y's and Z's and sometimes even things like X squareds. So what is a different concrete example that we can use in order to still take the same kind of idea of apples and bananas and put it towards these variables? Well, let's start off with an example. I'm going to say, what if I have 3x plus 2x? Well, what does that mean? How can we understand that in the context of the whole apples and bananas thing? I want you to imagine that what 3x means is I actually have three, I'm going to write this out, I have 3 x's, meaning, imagine I have these little tiles here and I have 3 of them. Or you can do it with a scrap piece of paper, a little sheet of paper, and you just write an X on it. So think of it as an actual X. So I have 3 of these X's, 1, 2, 3, and I'm adding 2 more X's to the pile. 1, 1 and 2. And so the question then becomes, well, what do I have now? So not memorizing math, but thinking about it logically. If I have 3 x's and I add 2 more x's, well, what do I have? I have 5 x's. So that's all it is when you're dealing with letters that aren't A and B. It works as well if I say, let's give you another example. So in this example, I not only have x's, but I have y's. But let's use the same tile or scrap piece of paper idea. So 4 x's means I'm going to take 4 of these. 1, 2, 3, 4. 1 y. Okay, and this plus 1x means I'm going to add to the pile another x. So now what do we have in this situation? I have a pile of 4 x's and I have a 1x. So altogether, I can see that I have 5 x's. Now, not only do I have 5 x's, but that accounts for these, I also have 1 y. So and, which is a plus, 1 y. And as mentioned before, we don't need the 1 in front of the y, so we can write it this way. Now in the question I wrote 1 just to reiterate it, to make it obvious, but if the question just says y, we have to know that there's an invisible 1 there as well. Now often what we say is we can take this equation and we can rearrange, or we can group like terms. Now what that means is when we're counting these tiles, it kind of made sense for us to say, well, let's bring that 1 beside or with the 4x group because it's easier for us to count them, 1, 2, 3, 4, 5. So when we write that algebraically, we're going to say, well, let's take this plus 1 tile and stick it right beside the plus 4x. Okay, so I'm going to write it this way. And then I still have my plus 1y. Always put an equal sign down so that we're showing that this line is equivalent to this one. And now that just makes it a little bit easier for us because now that we've grouped our like terms together, they are side by side. So you can underline that to help you focus a bit. And this says, hey, let's just deal with the x's first. So this gives me 5 x's and I still have 1 y, or just a y. Now I can't go any further than that because I can't say, oh, that's 6 of something. Well, yes, but you can't add x's and y's together. You can't merge them. And we can see this because looking at the picture, it would not make sense to say, oh, that's the same as 6x. Well, no, I have 5 x's. And I also can't look at it and say, oh, that's 6y. Well, no, because I only have 1 y. So our final answer is that. What about when we're subtracting like terms? So I have a question here where I have, let's take 5 x's. Okay, so I've got 5 x's here. and I want to subtract 2. So in this case, because I'm taking away, instead of adding or showing that there's an extra x getting lumped in, I'm not going to put anything down here, but instead I'm going to cross off 2 of those x's. So what do I have left? I have 1, 2, 3. I have 3 x's left. Okay, so hopefully that makes sense. That also helps us understand questions like this. What if I have 3x take away 3x? So I want you to pause the video if you're able to and take a guess about what you think your answer would be. Again, don't worry if you're not sure. And then come on back when you're done. All right, well, the answer you get is actually 0, just 0. And the reason is because if I start off with 3 x's, literally 3 x tiles, and I want to take away 3 of them, well, 1, 2, 3, I have nothing left. I have just 0, not 0x, it's just 0. I have nothing. And I really like this analogy because as you start to learn a lot more rules, sometimes I have students who look at this question and say, well, should it just be a 3? Why is there even an x after that? But if you think about it in terms of tiles, 5 x's minus 2 x's, the x is almost like a unit, like 5 meters minus 2 meters gives you 3 meters. Okay, so thinking of it that way tends to help you avoid some confusion and some issues. Now, what about questions that have more complicated variables? So what if I had a 3x squared plus 2x squared? How would I do that? So if I'm using this tile analogy, now I want you to imagine that I have 3 tiles. And what should each tile say? So let's think through this. When we had 4 x's, each tile said x. When I had 1 y, my tile said y. So if I have 3x squareds, and I want you to be very clear about this squared only applies to the x. So really, this is what I'm talking about for my tile. So each tile is going to say x squared in it. So this now means 3 tiles that say x squared on it. Now I'm going to add 2 of those tiles. So let me just duplicate this. And that's what this 2x squared means. I have 2 of this tile. If I add them, I'm combining it all. What should I get? Okay, so now if I look at my picture, 1, 2, 3, 4, 5. I have 5, but 5 what? I have to state the x squared. Okay, so the exponent doesn't change. It doesn't become a 4. Again, as you start to learn exponent rules and other things, sometimes rules get mixed up. But coming back to this analogy should help you sort through the, is it this or should it be that kind of question. Couple more just to really make sure you're understanding. This analogy works for terms that have a little bit more going on. So how do I interpret this? Well, the 3 is still my coefficient. It tells me how many tiles I have. So here the 3 tells me how many tiles I have. Everything after it tells me what's written on the tile. So how would I draw this one out? Well, I would actually just say I have 3 and I'd have XY written on that tile. So I'd have 3 tiles and they all say XY, 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 and I'm going to add it to one more tile that says XY. So in that way, hopefully you can see that we have 4 XYs. If you found this video helpful, please like and subscribe.